start with the new concept, that is positive deviation from Raoult's law. So here you can see here the graph which shows the mole fraction on x-axis and vapor pressure on the y-axis. So here there is a vapor pressure, it is given on the y-axis. So these dotted lines, these are the ideal conditions which is followed by this Raoult's law. So means if the solution of the solvent, it follows the Raoult's law. So this is shown by those dotted lines. You can see there is some positive deviation for each and every line which is shown here. This is P1, this is P2, and this is the total vapor pressure of the solution. Now if the solution is following this Raoult's law, so the total vapor pressure of solution would be equal to partial vapor pressure of component A or 1 plus partial vapor pressure of component B or 2, that is P1 plus P2, that will be equal to P total. We have discussed a lot about this Raoult's law in the earlier videos also. So in these cases, AB interactions will be equal to AA interactions plus BB interactions. This is the condition for ideality. So what are these A and B? These are the component of the solution. The solution is made up of two components, A and B. So naturally these two components will have the interactions in between them. So these interactions, if those are, one of the component might be solute and other might be solvent also. So this interaction between this solute solvent will be equal to the solvent solvent interaction plus solute solute interaction, which is denoted by AA and BB interactions. So this is the condition for ideality. Now in case of this positive deviation from Raoult's law, what is happening to this AB interactions? These AB interactions or 1-2 interactions are less than AA interactions plus BB interaction. So there is a decrease in the interactions between the components like solute and solvent. It means that there is a decrease in the interaction between component A and B, which is less than the interactions between AA component or AA interactions plus BB interactions. So this addition of these two interactions, these AB interactions are less than the addition of these two interactions, that is AA interactions and BB interactions. So these AB interactions, it results after mixing two components A and B. Now we proceed for the next slide here. If you go to the next slide, you can see here AA interactions are those which are taking place within component A or 1. You might denote this as a 1 or A. It is one and the same thing. This BB interactions, it occurs within component B or 2. Now after mixing, what happens to these AA and BB interactions is after mixing component A and B in liquid form, the AB interactions of the mixture of solution is very weak in comparison with their individual AA and BB interactions. Means when you add these A and B components together, these interactions between these two components will decrease here. So in solution phase, the interaction between molecules of component A and B are weaker. So the molecules of component A and B, they will go away from each other or they will not come closer to each other. One and the same thing. So here, due to this, what will happen if the component A and component B, after mixing together, they are going away from each other. So the volume of the solution will be risen up or increase. If you are mixing two things together, that is component A and B, and if you mix them together, after mixing, the volume of this solution will increase or it will rise up. It means that change in volume of mixing, it is greater than 0. Means interaction between component A and B are weak. So due to this delta V mixing, it will be greater than 0. So due to weak AB interaction, stability of the liquid mixture is lost. The molecules of component A and B were stable individually, but after mixing, they lose stability, and to achieve the stability, they absorb energy, and this change in enthalpy will increase here due to this absorption of energy. So why are they absorbing the energy? Just to become the stable, but because when we mix them together, they are losing their stability. So this delta H of mixing, that is change in enthalpy after mixing component A and B, as they are absorbing the energy, it will be positive here. So the total vapor pressure of the solution, it will be greater than partial vapor pressure of component A plus partial vapor pressure of component B here. Now this total vapor pressure, it will be greater than P1 plus P2, because we denote this partial vapor pressure for component A as P1, and for partial vapor pressure of component B, that will be as P2. Now if we come back to this graph here, you can see that there is a positive deviation in the values of P1 and P2, and that is resulting due to the weaker interaction. So these weak interactions between the solvent and the solute molecules, it will result in the increase in the total vapor pressure of the solution. The addition of these two partial vapor pressure of the component A and B, it will be less than the total vapor pressure of the solution. Means as the interactions are decreasing, that results in the increase in the vapor pressure of the solutions. The interaction between A and B components means solute and solvent. Okay, so this is nothing but the positive deviation from the Raoult's law. Now come back to the next slide. Here we proceed with this total vapor pressure of the solution. As we all know, that is the addition of this P naught of 1 into x1, P naught of 2 into x2. So if this is the greater, this is total vapor pressure is having the greater value than the addition of these two components, it will show the positive deviation. For example, we can explain this by taking example of ethanol and water. If we take 10 ml of water and 10 ml of ethanol here, the total volume of this solution is expected to be 20.2 ml, but it was found to be total volume is expected to be 20 ml, but it was found to be 20.2 ml. So there is an increase in the volume by 0.2 ml. What is the reason for this increase here? Now you can see here, this is the water molecule. It forms 4 hydrogen bonds surrounding this each water molecule. This is 1, this is 2, 3 and 4. So the hydrogen bonding, these are shown by the red color dotted lines here. So this hydrogen bonds are quite stronger one. Whereas in case of this ethanol molecule, it forms the hydrogen bond in this way here, and there is one more possibility here. It can form a one more bond here also. So comparatively, this is a stronger bond which is formed between these water molecules. Now when you mix these two things together, what happens? After mixing these two things together, this is the ethanol molecule. It binds with the another water molecule when they are mixed together, and it forms 2 hydrogen bonds. And this ethyl group here, which is a steric group, it does not form hydrogen bond. So due to the presence of this steric group, there is a decrease in the interaction. So on addition or on mixing of 2 solvents together, now we can call it as a solution. This decreases the interaction between the ethanol and the water molecule, and that increases the total vapor pressure of the solution, isn't it? Means if there are weak interaction, that will vaporize more readily, so that increases the vapor pressure of the solution here. That is nothing but the positive deviation from the Raoult's law. So due to this 4 hydrogen bond, H2O is less volatile, whereas this ethanol forms 2 hydrogen bonds, so it is more volatile, and hydrogen bonds are quite a stronger bond. When these are mixed together, the hydrogen bond formed are weakened, and there is a repulsion between alkyl part of the ethanol and polar H2O molecule. You can see here, there is a this is the alkyl part or the ethyl part of this ethanol molecule, and this is the water molecule. So there is a repulsion between these two things, and the result of this repulsion is that the polar H2 molecule, these hydrogen bonds are weakened. To stabilize this, it absorbs some energy, and this is nothing but the enthalpy change. So this enthalpy change for this such type of mixture which is forming, it would be positive. It absorbs some energy to stabilize the interaction between them. So this is the same thing I repeated, which I explained in the earlier slides. So the repulsion between ethanol and water results in increase in volume of the solution. Means delta V of mixing, that will be greater than 0. You can see here in this slide that there is an increase in the volume. It was expected to be 20 ml, but it is found to be 20.2 ml. So this increase or rise in the volume, that is zero point 0.2 ml, that is due to the weak interaction between the ethanol and water molecule. Isn't it? Now, the next, the interaction between these, that is the polar and non-polar. So actually this term is non-polar, here it is used as a comparatively. Water is more polar than ethanol. So will be weaker than the interaction between these liquids in pure form. So the tendency of these molecules to escape in gas phase increases as enthalpy of the system increases. That leads to the positive deviation. It means that the interaction between this ethanol and water molecule will be weaker, as we have discussed earlier, than the interactions between the liquids, that is ethanol and water. When they were in pure form, the interaction between them is more than they were mixed together. So the tendency of these molecules to escape in gas phase increases. Means when they are mixed together, the tendency of them to escape in gas phase, it will increase because it is absorbing the energy, and delta H, that is increasing, and that leads to the increase in the total vapor pressure of the solution. Means though the interactions are weakening, there is increase in the total vapor pressure of the solution, and that is nothing but what we call as the positive deviation. Means there is an inverse relation between these. Means if the interactions are weakening between the components which we are mixing together, that leads to the positive deviation, because there is increase in the total vapor pressure of the solution after we mix the component A and B. Okay, so this is all about the positive deviation. In the next video, we will we will talk about this negative deviation. Thank you.